very good afternoon to all. A good quotation by Benjamin Franklin. Tell me and I forget. Teach me and I may remember. Involve me and I learn. With this, I, Professor Smita Rai, feel privileged to be a part of the discussion that is crucial in shaping the future of aspiring engineers. The importance and hands-on experience in mechanical engineering careers. Mechanical engineering. Moving on, what is and how it might have a good progress in the career. Moving to the session of today, the program schedule goes like this. Introduction of the speaker by Smita Rai. About the institution, Pramod Kumar Prusti, Principal IIMT Bhubaneswar. On the topic, we have an eminent speaker, Dr. Rabindra Narayan Mahapatra. Feedback interaction by the participants. Last but not the least, vote of thanks, that's gratitude. Mechanical engineer, moving to a technical glance, is not about the theories or equations. It's about idea coming into life and solving the real world problems. Innovating better future, better lifestyle, better design.
Yeah, Smita.
Yes, sir.
Hello. Smita, recording on करino की?
Sir, on अच्छी?
On अच्छी कोठी देखो हाँ okay go ahead. Sorry
Okay.
mobile
It's
recording
okay.
so
Okay.
you repeat again हैं मुळुरु करते.
Okay. Sir, मुळुरु कहिबे?
माने disturb हो गला ना मुळुरु करते.
Okay. A very good afternoon to all. A good quotation by Benjamin Franklin. Tell me and I forget. Teach me and I may remember. Involve me and I learn. With this, I, Professor Smita Rai, feel privileged to be a part of the discussion that is crucial in shaping the future of aspiring engineers. The importance and hands-on experience in mechanical engineering careers. Program schedule for today's session. Introduction of the speaker by Smita Rai. About the institution, Professor Dr. Pramod Kumar Prusti, Principal IIMT Bhubaneswar. Talk on the topic, Professor Dr. Rabindra Narayan Mahapatra, NIT Agartala. Feedback and interaction by the participants. Last but not the least, vote of thanks. Moving on for our technical pathway glance of mechanical engineering. Mechanical engineering is not about theories and equations. It's about ideas, converting into reality, real-world problem, solving it, and making an innovation for a better future. While academic knowledge forms the foundation, practical experience that help in transferring the concept into reality. So whether it is designing machines, say deep software, CAD software, or engaging in industrial projects, all lies on the hands-on learning is what the engineers are truly capable. So today we explore how practical exposure enhance technical skill, foster innovations, and make graduates into industry ready. We will also discuss why companies value on hands-on experience and how one student can bridge the gap between the academic and industry demands. So let's dive into the fascinating journey of learning by doing and discover why hands-on experience is the key to success in mechanical engineering careers. To give us a deep understanding, we have with us the versatile and accomplished speaker who has made a remarkable contribution in the field of mechanical engineering. His extensive experience has guided and mentors many aspiring engineers to excel in their own career. He is none other than Professor Dr. Rabindra Narayan Mahapatra, Head of the Department, Production Engineering, NIT Agartala. Moving on to his profile, he is a distinguished professor in mechanical engineering with an academic experience in research, academia, professional consultancy, and serving as a professor in NIT Agartala, which has held his position earlier in NIT Meghalaya, SOA University, and other reputed institutions. He holds PhD in NIT Rourkela and has a strong academic background with his degree in production engineering, human resource management, and related fields. Over the decades of teaching experience, Dr. Mahapatra has contributed significantly to subjects like manufacturing science, industrial engineering, and supply chain management. His research interest lies in the area of manufacturing process, robotics, supply chain management, and green composite. He has published numerous research papers in reputed international journals, including Springer, IEEE, and has presented at global conference. Dr. Mahapatra has also played a crucial role in guiding research projects, supervising students, and conducting FDP, that's Faculty Development Program, on deep learning, artificial intelligence, and mechanical engineering advance. His professional membership include ISTE, ASME, and IET. Beyond his academy, he has involved in consultancy, industry institution, interaction programs, and laboratory development, including the Center of Robotics and Mechatronics at NIT Meghalaya. His contributions have significantly advanced in engineering, education, research, and professional training in India. As an educator, he has mentored students, guided research projects, and played a key role in his curriculum development. In his dedications to his innovation, he has made a valuable asset in both academy and industry. Thank you so much, sir. We are really honored to have you today with us. Now, time to make our prestigious institutions to make sir more introductive. Now, to give this, I request the principal of IIMT, Professor Dr. Pramod Kumar Prushti, to share few words for our prestigious institutions. Over to you, sir. Thank you.
Jai Jagannath, very good afternoon to one and all. I am Professor Dr. Pramod Kumar Prushti, Principal, IIMT Bhubaneswar, Odisha. Take this privilege to brief you about our institute and its activities. At the outset, I welcome Professor Dr. Rabindranath Mahapatra, NEET Agartala, our today's keynote speaker on career prospects in engineering and technology. I also welcome Professor Dr. Shrikant Patnaik, our esteemed founder cum Chairman of IIMT Bhubaneswar. Let me speak a few words about our institute, IIMT Bhubaneswar. IIMT Bhubaneswar stands for InterScience Institute of Management and Technology Bhubaneswar, which was established in the year 2007 with an objective of teaching science of management in addition to the practice of management. The name itself explains about the scientific study of management, and further to mention that it is inscribed in our institute logo. We are a UNESCO Unity Institute of UNESCO Chair, Professor of Economic Systems and Human Rights, Professor Francisco Vigliarolo, National University of La Plata. Let me now explain what we mean by teaching science of management. During these 15 years of excellence, we have organized, facilitated more than 100 symposium, seminar, workshops, national and international, in various niche areas of management and technology. Since our inception, we at IIMT have edited and published more than 100 volumes in the area of management and technology from reputed publishing houses like IEEE, ACM, Springer, Elsevier, iOS, SPY, Fluor Academic, MDPI, Hindawi, or InterScience, etc. All these books are available for purchase from Google or Amazon. All our faculty members are engaged in these activities. Each year, we invite and host professors from abroad for workshops and seminars. I am tempted to say that last year, Professor Jesus Garcia from Universidad Complutense de Madrid and Professor Vijayan Sugmaran from Auckland University School of Business visited our campus. During the month of April 2023, Professor Vipul Jain was here from Victoria University, Wellington, for a month on a research exchange program. We establish management books, we publish management books through our own in-house publication, that is IIMT lecture notes on management, where we publish the essential books like self-management, career guidance, and emerging fields of management. We have started our own channel, namely IIMT Open House in YouTube. The purpose is to educate students and parents at large on various subjects and disciplines through talks and interviews. By now, we have more than 100 episodes available at our YouTube channel, namely at the rate IIMT Open House. We have taken interviews with professors, professionals, entrepreneurs, and policymakers. From the academic session 2025-26, apart from the management courses of BBA and MBA and computer application courses of PCA and MCA, we will be entering into engineering courses, providing wide range of opportunities for our students. The courses offered are for BTech program, civil engineering, computer science and engineering, artificial intelligence and machine learning, computer science and engineering, cyber security, electrical engineering, mechanical engineering, and so on. For MTech program, computer science and engineering, artificial intelligence and machine learning. IIMT Bhubaneswar offers scholarships and awards to recognize and encourage academic excellence among students in science, technology, engineering, and management fields. Sponsored by renowned personalities, these awards celebrate achievements such as the highest CGPA and exceptional performance in specific subjects, fostering innovation and dedication among students. We have created a platform known as InterScience Research Network, consisting of professionals and researchers. It is available at www.interscience.ac.in, through which we organize various programs inside and outside India. We do arrange workshops and seminars at various universities. Thank you all.
Thank you so much, sir, for introducing the college profile in a high manner. Without wasting any more time, it's time for our esteemed speaker to speak on the topic. Over to you, sir. Sir, if you want to share your slide, you can.
I'm trying it.
Yes, sir. I have stopped sharing my slide.
Am I audible?
Yes, sir. You are audible and your slide is also visible. You can carry forward, sir.
Okay. Thank you. Very good afternoon to one and all. Professor Srikant Patnaik, eminent personality, shaping the modern education in Odisha as well as India. Thank you, sir. And the Honorable Principal, Professor Dr. Pramod Kumar Prusti, Principal IIMT Bhubaneswar, and Professor in charge training and placement, Ms. Smita Rai. So let me talk about this importance and hands-on experience in mechanical engineering careers. So this will be the outline. Now, before starting this one, let me tell you this mechanical engineering that has changed a little bit. What we are studying in our time in mechanical engineering and now the students studying in mechanical engineering, there is a gap. You can say that depending on the requirements, we have changed the things. The core branches are changing as per the demand of the situation. So we'll discuss all the aspects of this one. So starting from introduction, this is this mechanical engineering. It's the application of principles and problem solving techniques of engineering from design to manufacturing and to marketplace. Now, initially it was only design to manufacturing, to the marketplace that has been introduced nowadays. So in the late 90s, you can say, this marketplace is added to this mechanical engineering. Initially, it was a part of MBA. We're not dealing with this marketplace, how to market the product, how to sell it, whether it is sellable or not. So this part is added newly. That is for any object. We see that one also. Look after this one also as a mechanical engineering. We analyze the work using the principle of motion, energy, and force. This kind of things we have studied in our kind of thing, we call it in the preparatory classes in +2, regarding the motion, regarding the energy, regarding the force. So we combine these three things, motion, energy, and force, and ensuring the design functions safely, efficiently, reliably, and the cost is competitive. That is another important parameter. So by combining these all, mechanical engineers, they generally make a difference because they do what the human wants. Virtually every product or service. Now see, this service is introduced here. Initially, the mechanical engineering was dealing with products only. Now it is added the service. So this is the change we have made in subsequent years. Now, if we go on describing difference between product and service, modus operandi of both the cases, there are service organization, there are manufacturing organization, depends on the end product. Now, if the end product, we can say it is tangible, touch and feel kind of thing, we call it as the manufacturing organization. And if it is intangible in nature, the output, then we call it that one as the service organization. So we cover both. That's why every product or service in modern life has probably been touched by in some way by the mechanical engineer, whatever the kind of product, whatever the kind of service. So always we find this, the involvement of mechanical engineering is there. So what these mechanical engineers, they do? They deal with lot many aspects like the things, acoustics, aerospace, automation, automotive, autonomous system, biotechnology, composites. So there are many such fields where these mechanical engineers, they operate. Anything moving parts needs the expertise of a mechanical engineer, they do it. So that is why the mechanical engineering combines creativity, knowledge, analytical tools to complete the difficult task of shaping idea into reality. Everybody must be certain ideas, not only for the mechanical, but any branch of science or engineering. People are having so many ideas. Even the common man, he is having some idea. Might be at some times he might be thinking of doing certain things. But is the transformation happening? That is important. So this transformation, it is taught to the mechanical engineering people. So they can do it in a systematic way, in a coordinated way, at a personal scale, affecting the human lives. On a level, we can reach out and touch, like robotic prosthesis, we do it. It happens in the local scale, affecting people in the country level. So that is what the mechanical engineering means a lot. On a bigger scale, like with the advanced power systems, through engineering that operates nationwide or across the globe. So that you can do. So mechanical engineering is important. enormous range of opportunities. And because of this, we should go for mechanical engineering. This is one of the core branches. Initially, the core branches were civil, electrical, and mechanical only. Now it is culminated into different branches, like new branches are coming up. So we have to also look into that one, and we have to see how the mechanical engineering is related to those sister branches. If we consider the jobs in mechanical engineering, job types. Mechanical engineering, they play a vital role in aerospace industry, contributing to various aspects of aircraft and spacecraft design, development and maintenance. So in aerospace engineering, the application of mechanical engineering is a must. Coming to this, there are two branches of science or physics, we can say statics and dynamics. Statics is that we deal with non-moving parts. So here the research of mechanical engineering focuses on how forces are transmitted to and throughout a structure to make it stable. But once the system in motion, we change into look into dynamics of the system, moving parts. We consider about these velocities, accelerations, resulting forces that come into play, kinematics. So these are the things we deal in statics and dynamics also. We deal with material sciences. Material sciences, that is the best material that is meant for that proper application for a particular field. Now, initially, material sciences were not that much developed, but nowadays, it is developed much because of introduction of this hybrid materials, composites. So we give emphasis on the material strength, supporting loads, stiffness, brittleness, and other properties. And that we consider as one of the important parameter in many construction, automobile, and medical materials. So the mechanical engineering deals with material sciences also. Also, we deal with the energy efficiency that converted into useful power. The kind of energy, heat transfer that is crucial in many applications. So gathering and analyzing temperature data and distributions that we deal in the branch of mechanical engineering, that is more appropriately the thermodynamics. That also we have studied earlier, and we are going to go for the application part. Again, it is fluid mechanics, the another part. So if you go for fluid mechanics, that is fluid, you can consider it is versatile. It has got variety of applications. Properties including pressure, pressure drop, fluid flow, aerodynamic, drag force. So these are the kind of things we deal in the fluid mechanics. Coming to manufacturing, manufacturing is one of the important aspects of mechanical engineering. So researchers here investigate the best processes to make the manufacturing more efficient. Here I want to add one thing. All these things should be done in a coordinated way. Like there is a term, we call it as the process planning in mechanical engineering. That you are given a task, you have to make a product, you have to manufacture a product, but there are different steps you have to follow one after another. Like you do in the project management. You want to execute a project, there are certain tasks you have to do at certain point of time, and it should be coordinated. If it is not coordinated, then the things, either the efficiency comes down or you may not get the end result. That is why I always emphasize the work should be done in a coordinated way for any engineering, not only mechanical. If I want to give you one example, there's a very simple example given. If we talk about, let me tell you a story. Once in summer, two persons were working in a field. One person was digging a hole, and the person behind him, he was filling the hole. One person standing outside is taking rest under a tree. It was hot summer. Then he was looking at them that what the workers were doing. So he waited for nearly about 20-30 minutes. He found that one person is digging a hole and the person behind him is filling the hole. So he couldn't resist his temptation. He went to them and asked, what you people are doing? So they answered, we are doing our work. What kind of work you are doing? The first person said, I am paid for this to dig a hole. The second person told that I am paid for to fill the hole. So both are paid. Both are doing their work. And the person thought, then why you are doing it? So they said simple answer was to get money. Then what is the utility? Then those persons, two persons, they replied, the middleman is absent. Actually, he has to plant a plant there, plant a tree. So because of the middleman is absent, the first person digging the hole, middleman should plant a tree there, and the third person should fill the hole. So both the persons are doing their work, but not in a coordinated way. End result is 0. So that is what I want to make it clear. Whatever you do it in a coordinated way. Now coming to the skills. So there are different skills. These mechanical engineering people, they do. The essence of mechanical engineering is problem solving. Problems can be of different types. Once you got a problem, you have to think of that. In a difficult problems can be solved maybe in the most easiest way, if you think it properly. The difference we should learn, we should not study. Now studying and learning is different. If you study the thing, you only become a kind of thing, bookworm kind of thing. You study whatever is given in the book, you study it, mug it up, remember it. So remembering and forgetting, that is the most common type of things people do. But the problem here, we are not to study, we have to learn. If you go for the psychological meaning of learning, it is the change in behavior more or less permanently. That is learning. So you study it, apply it, get confidence. Your behavior will change automatically. You can handle the problem. You can foresee certain result. So that is what learning means. Learning means a lot. So only studying will not solve the purpose. So there should be motivation. There should be interpersonal skill, leadership, conflict management. So creating a product is a part of the equation. So you have to know every point of this. Now going for this different skills, what these people, mechanical people do have. They have the technical knowledge. Technical knowledge means fundamental knowledge, strong foundation in science. So strong foundation in physics, mathematics, and mechanics is crucial. That is for mechanical engineers. Understanding the principles of thermodynamics, fluid mechanics, material science, structural analysis forms the backbone of mechanical engineering. These things we have studied, but a thorough knowledge is needed in this particular thing. So technical know-how, technical knowledge, this is one of the essential skills. Next comes the problem solving. Mechanical engineers encounters complex problems. So analytical thinking is a must, and creative solution should be there. So the person should be able to break down the problems and develop innovative solutions. Now, a problem can be having many number of solutions, n number of solutions. But which one is the best, you have to think of it. So there are different tools and techniques available nowadays. Optimization technique is available. You can put your solutions into different optimization techniques to find out the best one that can be done. Next one, design and CAD. So that is the proficiency in computer-aided design software. AutoCAD, SolidWorks, similar kind of programs. Now in this case, instead of going for two-dimensional view, we can have the product in 3D view. Initially, what is happening, we go for the top view, front view in 2 dimensions only. Then we have to imagine the things. But because of this introduction of these softwares like SolidWorks, AutoCAD, these programs, they give us a solid modeling of this particular product. So you can see the product. Instead of imagining the product, we can see the product in the screen. So that is one of the interesting part in mechanical engineering. So that skill should be there in the mechanical engineers. Critical thinking, assessing risk, evaluating different design options, making decisions based on data and analysis are critical skills for mechanical engineers. So they should be critically think of a particular thing. Communication. Communication should be proper. Discussion with the team members. You should have sufficient knowledge how to communicate it properly. Technical information clearly. Next comes the project management. This project management is important. What is a project you think? There are different tasks combined in a specific order to get the result, achieve the goal. So managing the project, including budgeting, scheduling, coordinating with teams, suppliers, clients, is a part of mechanical engineer's role. Now see, here we come across another important parameters that we call it as the supply chain. Supply chain is a kind of thing starting from this supply of the materials into the system, mechanical system, manufacturing system, production system, whatever may be the system, convert it into a particular proper way, getting the output as a product or service. So there are different departments inside that one. Different operations are done. Once the raw material enter into this system, then transformation starts. What are the transformations? Like cutting, bending, finishing, super finishing, knurling, thread cutting. So there are different kind of operations. This raw material is subjected finally to be converted to the output. Depends on the output. If it is usable, that output we call it as a product. If it is not usable, we call that one as a scrap. So in every point of time, the operation we are making on that raw material, that should be value added one. So that the output, whatever we should get, that should be a kind of value added output. That you have to check. In project management, these things we know. And we manage every point, every steps in that conversion of that raw material into the finished product. Initially, it was there. In the traditional mechanical engineering, what was there? Like throwing the batons across the wall. Now there are departments like what you call design. There are departments called manufacturing. There are departments called finishing. Now once the design people, they do their work, they simply hand over this responsibility to the manufacturing people. The manufacturing people ask for the design and drawing from the design department, they make the product, send it to this finishing people. You do the finishing. So their work is over. But nowadays things are different. Now the things where instead of throwing the baton across the world, now we are going for a kind of special branch of engineering. We call that one as the concurrent engineering, where the experts from all the fields sit together, think of the particular goal, and try to do it in a better way. So that is what the project management is important. Next comes the hands-on application. This is the practical skills in building the prototypes, conducting experiments, testing, design, the valuable, testing and designs are valuable. Now see, what do you mean by a prototype? Before getting a product to be done, we have to test it. Now making the product, testing it, it is a kind of thing we call it as the time consuming, as well as if the product fails, we can suffer a huge loss to the organization or the company. So what do we do? We make a prototype first to test it. So prototypes are functionally as good as the original product, but in a small scale. So prototypes, we can test it physically, and nowadays softwares are available to make it test through using the programs. Different programs like your SolidWorks programs are available, simulations are available. You can simulate the product and find out whether it is working or not working and why it fails. Then you go on modifying it. So that is what you call the skills, developing a prototype, conducting experiments, things should be there. This is done at this pilot production stage. Before going to this high volume production or full scale production, when you go for making the product to happen in the pilot production stages, we go for building prototypes, testing it, making the product, sending it to the market, getting the feedback. So then we go for this high volume production. Then another important thing is the continuous learning or improvement. That has to be there. Teamwork. Now this teamwork is the multidisciplinary teams. Now the mechanical engineering is not related to the mechanical engineering only. They work with other branches of engineering also. Now, as the current people age, this technology demands more hybrid structures. So not only mechanical, any product you take up, there are different branches of engineering integrated all together. You can find there is mechanical, you find there is electrical, you find there is electronics, you find there are certain AI tools, computer systems are also operating. So all these systems are available in a particular product. So there should be a teamwork. Mechanical people, they should work with people from other branches, other departments, collaborate with them effectively. So that is essential for teamwork, and ethical standards should be maintained. That is one of the important parameters to maintain the ethics for the society as well as to the environment. Next, discussing about this future of engineering in India. if we go for discussing this one, we find this H1B visas only from India. This is 50% of H1B visas issued by the US government. And the most prominent bidders are the software companies hubs in India. So this is one of the important parameters, how it affects this future of engineering in India. But there is a capping on the US and UK visas. So this makes these engineers from India a bit restricted. If we go for this employment providers, in India we find it is Indian Railways, Indian Post, Indian Army, and SBI top of the list. These organizations, they require considerable engineers. And there are also software giants who hire engineers only. They are having a lion's share on this one, 92% of the engineers. These companies are TCS, Wipro, Infosys, IBM. And software outsourcing is the highest revenue generators for India. That has to be taken care. With the advancement of technology, India is also getting involved in neo technologies such as semiconductors, robotics, AI. More research options are available. And large multinational companies are now trying to get into India, ready to invest because of this talent we find in India. And we should not forget about these traditional organizations in manufacturing, oil and gas, petrochemicals, energy industries that requires engineers. Now come to this mechanical, chemical, civil, electrical. These organizations are Shell, NTPC, GIL, GAIL, ONGC, and many PSUs. And many private sectors are also having a lion's share on this recruitment of core branches, mechanical, civil, electrical. These big players are L&T, Reliance, Tata Steel, SR Steel. So these are the companies. So this is what our this future trend goes on, future engineering in India. Now coming to this next category, engineering colleges and regulations. If this large number of kind of things demand is increasing in India, so what about these colleges in India, engineering colleges? Currently, roughly we find 4,600 plus engineering colleges in India. And the number is going up every day. With growing number of colleges, increasing number of seats, regulatory committees are also becoming stricter. Norms and regulations are going stricter for a fair process, corruption-free education. So the college nowadays becoming or involving in this engineering education, they should be a little bit transparent and with a standard, ethical standard. That is also important. Now coming to the another aspect, this parental pressure and engineering. If we go to this before 1990, what we are thinking, most parents dream of their children studying nothing but engineering. So that was the trend in those days. Because once you pass the engineering, there is plenty of opportunities to get a job. And it was difficult to get the job in other fields. So the parents were thinking of getting their children to study engineering only. So there was a little bit of high pressure. Now the things are changing. People are also from other fields are getting good jobs. Like people continuing law, hotel management, they're also getting a high paying job. So now the alternate careers, these parents are trying to choose. Still, because of this inertia, nowadays also parents are choosing engineering as a kind of option for a better placement for their children. And if we go for this pursuit of engineering degree, this has also gone significantly up. People know this is again a high paying job. And they get it immediately after graduation. While if you go for these other courses, like graduation is not sufficient. You have to go for additional courses. While mechanical new fields, if we are talking about, while mechanical, civil, electrical, chemical engineering have become more old school and have taken a backseat in popularity chair, but not actually. Now, because of this change in the structure want in this modern world, the different fields like computer science, electronics, communication, aeronautical, biochemical, these are coming to the forefront. But always remember, everything people are doing, that should pass through this mechanical. Anything you make. Only leaving this pure software kind of thing. So more jobs are now becoming available in those fields. So biotech engineers nowadays also getting high paying jobs. The ISRO, Aeronautical Development Establishment, National Aeronautics Laboratory, HAL, they are also hiring these aeronautical engineers. That is also a branch of mechanical engineering. They also hire mechanical engineers and train them. And if we go for this next step, where it is headed actually. Now this technology, it always remains in a state of flux. Nobody can definitely predict the course of science and technology in which direction it is moving. It is not predictable. So to get a proper framework of this one is very difficult. The world needs the best minds to study and put the knowledge of such technologies to use. So in coming years, it will be more challenging. If you go for this, the world of mechanical engineering, staying informed about the latest trends is crucial to remain competitive and excel in your career as you step into 2025. So there are several developments in the mechanical engineering field, professions. So you have to think of that one also. So the mechanical engineering career, hands-on experience is crucial, as it allows these engineers to apply theoretical knowledge to the real world problems. develop critical thinking skills, and gain a deeper understanding of mechanical systems to practical applications. And if we go for coming to the major part of this presentation, hands-on experience in mechanical engineering. So actually, what is this hands-on experience? Now let me give you a very simple example. Like a person studying this mechanical engineering. So it is the automobile engineering also included there. So the mechanical engineering studies all about engines, this connecting parts, body parts, how the engine works. You take an example of a simple motorcycle. A mechanical engineer can design that engine, whether it is 2-stroke, 4-stroke, petrol engine, diesel engine, whatever. He can design an engine, he has that kind of ability. He can develop a particular bike, he can change its shape, make it aesthetically looking better. Everything he can do. But you compare that mechanical engineer to a person on the roadside mechanic who has not studied the mechanical engineering, but he has worked in this particular field, repair and maintenance, for last 20 years. So now see the impact of hands-on experience. This mechanical engineer who has studied, he can go for developing everything. But when the problem comes, only that person, this roadside mechanic, can solve that problem. The mechanical engineer cannot solve the problem because he is lacking hands-on experience in mechanical engineering. But the person sitting on the roadside, that mechanic, he is the better person to deal with this problem-solving part. So this is the first point of the hands-on experience in mechanical engineering. That is the problem solving. So this is related to practical experience that makes the engineers to identify and solve complex problems by applying their knowledge to the real world scenario. That is important. So you are allowed to work on hands-on experience in a particular field, in a particular machine, in a particular object. So you know everything about that particular object, particular machine, particular system. So enhances your ability to deal with this problem solving. Conceptual understanding, second point, comes in the hands-on experience. So working with these systems in the laboratories or on projects, so it helps to solidify the theoretical concept and enhances the ability to visualize how these mechanical components interact. You have studied about a machine, you worked on a machine. There lies the difference. The person who worked on a machine is more conceptually stronger as compared to the person who studied about that particular engine or machine. That is what it means. So hands-on experience is a must in mechanical engineering. Technical skill development. This hands-on experience allows engineers to refine their skills in dealing with these softwares. Either you can go for this CAD software, CATIA software, machining, assembling, testing. So these parts you have to learn it. And how to learn it? You have to go for this technical skill development kind of programs to learn and use it properly, to optimize the system. Industry awareness. So participating in internship or these projects within an industry studying in education, also doing your careers in mechanical engineering, you should go for this internship programs. So that develops hands-on experience. Then comes the critical thinking. It increases the critical thinking in different situations. You can analyze the situation, consider different approaches to solve the particular problem. That happens on hands-on experience. Innovation and creativity, that also comes from this hands-on experience. How to gain it? This hands-on experience. It can be gained during your study of mechanical engineering. Like you can go for this internships programs. So you can participate in internships at different companies relevant to your desired specialization and get exposure to this real world engineering projects, capstone projects. So you can work on design and build projects as part of your academic curriculum. It helps in this combination of theoretical knowledge to practical applications. This capstone, this projects, it was initially the part of MBA some 10-15 years back. So people in the final year of MBA, they were given this capstone kind of project. But now it is common in engineering. People are doing it in the final year BTech. So it can develop your this kind of thing, hands-on experience in mechanical engineering. Laboratory work, you should be actively engaged in the laboratory experiments and exercise to learn about material properties, testing methods, system behaviors. So this can be done, and we think it is a kind of more helpful in learning. Increases your hands-on experience in mechanical engineering. You have to engage in research projects, participate in research projects to gain advanced knowledge and skill in some specific areas of mechanical engineering. You can go for this personal projects also. You can do the projects on the individual level, combining this theoretical knowledge and practical knowledge. Now coming to mechanical engineering growth. So this mechanical engineering projects that increases 9% from 14 to 25, 2014 to 2025. So there is a upward trend. If you go for this leading employers in 2025, this manufacturing expected to emerge as the leading employer of mechanical engineers 2025, accounting for a substantial 46.2% of the profession. So the manufacturing sector's dominance can be attributed to its continuous growth and transformation. So that is what this employment of mechanical engineering says. The rise of smart manufacturing, powered by technologies like IoT, big data, these are now in combination with mechanical engineering. Actually, it is combined with many branches of engineering, all branches of engineering. But if we combine these things to mechanical engineering, it can do miracles. So that is what the people are doing. So this traditional, manufacturers are embracing advanced technologies to enhance their production processes and deliver high quality product efficiently. which is shifting towards automation, innovation, robust demand for mechanical engineers to design, maintain, and optimize these systems. And finally, if you go for this latest technologies in mechanical industry, these are, we call it as the automation, computer-aided engineering, IoT, 3D printing, robotics, AI, nanotechnology. So these are these kind of things we can call as the latest technology in mechanical engineering. If you think about automation, is one of the driving force in mechanical engineering field. Major application is the automotive, aerospace, and manufacturing industries. So not only it streamlines the production processes, it reduces errors, enhances precisions, and boosts the productivity. As a whole, increasing the GDP of the nation. Computer-aided engineering now, this one also initially it was a computer-aided design, and now we call it computer-aided engineering as a kind of software tool that has to be used by the engineers to simulate and analyze complex systems and components. And this IoT in mechanical systems enables real-time data collection, remote monitoring. It helps in predictive maintenance and the system performance. 3D printing is a new technology added to mechanical engineering. Instead of making it the regenerative engineering, we call it additive engineering, we call it additive manufacturing, we call it. Now, instead of like we make a product in traditional engineering, what do? We take a raw material, cut it into shape. But here in 3D printing, we do not do that kind of thing. We generate the surfaces layer by layer. Instead of making it a cutting, we make the product to happen layer wise, keeping one layer over another layer. We build the product, generate the product. So that is what this 3D printing nowadays is kind of most demanding part in the mechanical engineering. Robotics, as everybody knows. So some industries use robotics as a repetitive kind of work and in different hazardous situations like welding, painting, assembling. So when the part is kind of work is repetitive, so we use this robotics. AI, nanotechnology, we deal with this material properties in the nano level, changing its the material structure, changing its stiffness, brittleness, malleability, ductility, everything we can change. We make a completely new material. The material behaves as a new material, we change it at the nano level. So this is what this mechanical engineering fields they can do. Now this demand of mechanical engineering, it comes of this three predictive and control engineering, material response and wear, and human response, human machine interaction. So that is what this mechanical engineering as a whole, I can say it can stay ahead of all branches of engineering, but subject to that you should encompasses all these parameters, the modern tools available. You cannot do it individually, but with a teamwork, with multidisciplinary concurrent engineering, you can do a miracle. So that is what all. Now you can go for this questionnaire section.
Thank you so much, sir. Your word, you have inspired and showed us how innovative ideas and solutions are a better career in mechanical engineer. Thank you so much, sir, for showing us the path and the career towards the mechanical engineer. Time to gratitude. I take an honor on behalf of IIMT to esteemed guests for delivering such an insightful, engaging, and thought-provoking sessions. Your expertise, your value experience, and profound knowledge have truly enlightened and inspired all of us. I sincerely thank our respected principal for his presence, his support, guidance, and visionary leader, always inspired to continue in a better way for our prestigious institutions. Last but not the least, I thank all the participants for actively listening. Thank you so much. Thank you, everyone.